Section 2.6 is about limits at infinity, and that's going to include limits as we approach negative infinity and limits as we approach positive infinity. It's also about horizontal asymptotes. I want to just point out horizontal asymptotes is one possible thing that we can describe using limits at infinity, but it's not the only thing. Okay. So let's just start with an example. If y is equal to e to the x, I know what that graph looks like. That's an exponential growth graph, like so. Okay. Now, if I take the limit as x goes to infinity of e to the x, okay. We haven't seen this before. We've always seen x approaching a finite number. We've come across infinity and negative infinity, but only as the result of taking the limit. So we've seen that our y values, the outputs of our function, can go off to infinity or negative infinity. We haven't encountered this before. But this is just saying x is getting big in the positive direction. Often limits in infinity are described as describing the end behavior of the function. What happens as I just keep going infinitely far to the right? Now, if I follow this graph infinitely far to the right, I see that my y values are going infinitely high up. And so here, we would say that this limit is infinity. And what that means is just as x goes to infinity, e to the x, the y value on my graph, goes to infinity as well. Now, this is informal. As we work through this section, we'll get to the formal definition here. But we basically know what this means. This means x is getting really, really big in the positive direction. Now, if I look at the limit as x goes to negative infinity of e to the x, that's describing the end behavior on the left side of the graph. What happens if I follow this graph and keep following it, going arbitrarily far to the left? And I can see here the y values are getting smaller and smaller and smaller. They're approaching the y value of the horizontal asymptote, which is the x-axis. So we would say that this is equal to 0. So here's a situation where we're seeing a horizontal asymptote. So not all limits at infinity are going to be horizontal asymptotes, but if the limit as I go off to infinity or negative infinity is a finite number, that's saying as I go really far to the right or really far to the left, the graph is leveling out at that height. And that's how we would describe, using limits, a horizontal asymptote. So I want to just compare now how we describe vertical asymptotes, what limits describe vertical asymptotes, what sorts of limits describe horizontal asymptotes, and then what sort of limits describe no asymptote at all. Okay. So if I have a vertical asymptote, I'm just going to draw a picture of a graph that has several vertical asymptotes. Maybe on this one, we're going up on both sides. For this one, we're going down on both sides. And for this one, we're going up on one side and down on another. But for any of these vertical asymptotes, what's going to happen is x is approaching a finite number. That would be the location of the asymptote. And f of x is going to infinity, or f of x is going to negative infinity. And of course, in the case of something like this, I would have to approach the number from the left or from the right to determine whether my function values were going off to positive infinity, which here they are from the left, or negative infinity, which here they are from the right. Okay. If I have a horizontal asymptote, let's just suppose I have a function that looks like this. I'm going to have the same horizontal asymptote here on both sides. Okay. In this case, we would have x is going to infinity, or x is going to negative infinity, and f of x is going to a finite number. So I'm going to have an asymptote of some sort if one variable is approaching a number and the other variable is approaching plus or minus infinity. If it's the y value that's getting super big, well, y gets super big. If we're going really high up or really low down, that's going to be a vertical asymptote. If it's the x value that's getting really big in either the positive or the negative direction, that's what's going to give me a horizontal asymptote. Okay. And then, of course, if both x and y are approaching numbers, or if they're both approaching plus or minus infinity, then I don't have an asymptote at all. Okay. So I'm only going to have an asymptote if one variable is approaching something finite and the other variable is approaching something infinite. Okay. So horizontal asymptotes are the types of asymptotes we're going to see in this section, because this section is all about taking a look at what happens if x gets really, really big and positive, or really, really big and negative, as x is the variable that's getting infinitely big in one of the directions. And if the limit is a finite number, we will have a horizontal asymptote. If it's not, we won't. But either way, we'll be able to describe the end behavior of our function. So as we work through this section, we're going to develop some new techniques for being able to deal with that.